Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear?
Yes, sir.
Fine, thank you. And sorry for the delay. PySpark, right? Yes, today I'll be discussing about the following topics, right? What is Apache Spark? Why PySpark? Need for PySpark? Spark, Python, and Scala, and PySpark features, real-time usage of PySpark and PySpark job market. Right? Yes. Let me have a overview. What? Okay. So Apache Spark, right? It was developed by Matai Zaharia in AMP lab. It was developed. Spark was developed in the year 2009. It was open sourced in the year 2010. It was donated to Apache Software Foundation in the year 2013. Used for big data analysis and for processing and for computation, right? Used for big data analysis, processing and computation, right? So if I can define Spark in 5 lines, I can define Spark in 5 lines. It is an open source. Spark is a open source distributed execution framework. You see, right? Distributed execution, cluster computed, in-memory computation. In-memory computation means storage and processing both happens within the memory level, and parallel process style for large scale data processing, right? Yes. So distributed, cluster computed, open source, in-memory, everything. What Peter we see in Spark is in-memory, storage within the memory, processing within the memory, right? Parallel process style for large scale data processing, right? Okay. So Spark can be coded with not only like Python, right? It can also be coded with Scala language. Spark by default built using Scala. So Spark, most of the Spark API you see in Scala language, but we can also use Python for implementing the Spark is an execution model implemented in multiple languages like Scala, Python, Java, and R language, right? Mostly used ones are Scala and Python. Python is mostly used these days, right? And why PySpark? PySpark is the Python API to use Spark, right? It is the Python API to use Spark. And PySpark is a lightning fast technology that is designed for fast computing, right? Yes. So Spark is it's one of the demanding tool among the data engineers, right? To work with bigger data sets. Okay. So PySpark main is used for distributed SQL queries, creating a data pipeline. So Spark is a data flow language. The output of one will be the input to the next flow, right? And data ingesting data to database, ML algorithms, machine learning algorithms, right? And for graphs or data streams. For graphs or data streams, right? So PySpark is preferred for all this. And PySpark packages, like PySpark itself is a package, PySpark.sql, PySpark.streaming, PySpark.ml, and PySpark.mllib, right? PySpark.sql, PySpark.streaming, PySpark.ml, PySpark.mllib. Okay. Spark is an execution model. Python is an programming language. Combined together, we say like PySpark. So most of them, which one to be preferred, Python or Scala, means both have got advantages. Both have got some disadvantage, right? Python is dynamic. Scala is static type. Based upon what value you are assigning, based on the value assigned, the variables are created dynamically here. Python has got huge community. Scala has got smaller as compared with Python. Python contains powerful libraries for ML and for graphs, less as compared with Python. I won't say like Python is always the great. As compared with Scala. It's faster as compared with Python. So PySpark main features are in-memory computation. So storage and processing both happening within the memory. Generally, if you see, storage happens within the disk, but here storage and processing both happens within the memory level. Lazy evaluated means PySpark or this PySpark, it's a data flow, gets executed only when we perform an action. The data flow gets executed only when we perform an action. It's a fault tolerant, that means multiple tasks executed by multiple slaves. Multiple tasks executed by multiple slaves. If any one slave goes down, see, multiple tasks are executed by multiple slave systems. If any one slave goes down, then the task will be allocated to any other slave. Then the task will be allocated to one. This is called fault tolerant. It has got powerful fault tolerant model. It has got powerful fault tolerant model, right? Yes. Okay, it's distributed. And its persistence means transformations can be reused. So all this will be discussing, right? Persistence means if you execute any transformation, tomorrow I want to reuse the transformation, can be reused here. Parallel processing. Your task is divided into multiple tasks executed by multiple systems parallelly, right? A real-time usage of PySpark, right? Right, for commercial sector, right? It is used for the commercial sector, right? For real-time processing systems, banks, and take the example of this, like banks and financial systems, they use Spark, right, to retrieve customer social media information. Once again, can anyone please confirm whether my voice is clear?
Yeah, it's clear.
Fine. So the healthcare, for example, today if we see a patient's records along with the previous medical history, identifying and predicting which patient is most probable to face the health issues even after being discharging, right? So even in the entertainment industry, right, Python today, like PySpark is mostly preferred, right? Even the most popular online entertainment platform Netflix uses Apache Spark for real-time processing to personalized online movies or web series, right? So it processes approximately 450 billion events. So it processes 450 billion events per day, right? And also for e-commerce, right? For websites like Flipkart, Amazon, like recommendations, pattern matchings, right? The other websites such as like Alibaba uses this. Even in the tourism industry, much preferred. It has got it has got a table, for example, motivation towards Spark, motivation towards PySpark. Motivation towards PySpark, right? Taking a table of 100 TB consisting of 1024 columns The task is sorting based on 16 columns. So time taken by the different time, what is the time taken by the different, like Oracle has taken 3.5 days, MySQL like 6 days, Teradata like 4.5 hours, Netezza like 3 hours, and finally Hadoop has taken 3.4 minutes. Where is this days, hours, and where is this minutes, right? Finally, PySpark, right? PySpark is 100 times faster than Hadoop. It is 100 times faster than Hadoop, right? Yes. See the speed of PySpark as compared with this Hadoop, which is already faster, right? Yeah. PySpark mainly designed for batch applications. Batch applications means user non-interactive applications. User interactive applications, we call it as online applications. But this PySpark is not online processing. It is for batch applications, millions and trillions of records, and for iterative algorithms, recursive algorithms, and for interactive queries, and for streaming, right? Interactive queries for SQL and for streaming, right? Fine. So you need to understand something about the Spark data objects. You need to understand something about the Spark data objects like RDDs. Spark data objects are called RDDs. And these RTDs are subdivided. RTDs are subdivided into partitions. Okay, 1 second. RTD data object. This RTD is subdivided into multiple parts. Observe. Partition 1, partition 2, partition 3, partition 4, partition 10, 10 partitions. This all these 10 partitions can see P1 in slave system 1, in system 2, this is in system 3, in system 4, in system 5, right? Yes. All this they can execute, all these 10 partitions, all these 10 partitions can execute parallelly. Okay, this S10, this is what S10. 10 partitions are executed parallelly. 10 partitions are executed parallelly by 10 systems. Only RTD1 output will be taken as input. This output, whatever you get, is taken as input by RTD2. RTD1 output is taken as input to the RTD2. In this way, again RTD2 partitions are divided into, and RTD2 output is taken as input by RTD3. So in this way, the data flow, right? One flow output is taken as input by the, yes. And this entire flow is a lazy evaluated. Lazy evaluated. Evaluated means, right? Once if you perform any action, then only the entire flow will be executed. Once we perform action, only the entire flow gets executed. Until then, it is not going to get executed, right? Yes. Okay. Okay, Spark is a data flow language, right? It's a sequence color. See, RTD programming style is data flow, right? Yes. Spark is a data flow language. RTD programming style is data flow. RTD is a Spark data object. Data flow is a sequence collection of pipes. Data flow is a sequence collection of pipes. Data flow is sequence collection of pipes. A pipe can be any data operation. A pipe can be any data operations like loading data, transforming data, filtering data, grouping data, merging data, right? Any kind of thing, right? In Spark, data flow is executed in sequence, RTD by RTD, one after the another. One after the another within in-memory computing feature and persisting feature, right? What is persistence? I'll discuss. Data flow. Two RTDs never execute in parallel. RTDs has got partitions, that partitions can execute in parallel. RTDs, but if a RTD has 30 partitions, so first I'll show you, right? I'll show you. So I'll just show you one diagram for this to make you understand, right? Yes, 1 second. Observe this diagram. I have drawn this in paint. 1 second. R1 to R2, R2 to R3, right? See this R1, RTD1, RTD2, RTD3. RTD1 output is taken by RTD2, 3, 4. See here, we see three different flows. Flow 1, R1, R2, R3, R4. R1, R2, R3, R4. Second flow, R1, R2, R3, R5, R7. This one, R2, R7. Third flow, R1, R2, R3, R6, R8. To execute any flow, flow 1 or flow 2 or flow 3, right? Action need to be performed. Means generally, if you perform action only, then this flows gets executed. We have got some actions, inbuilt actions are available. So if you want to execute the first flow action, some of the actions like a collect, count, right? Actions. Inbuilt actions. Collect is one action. Count is one action. Collect is one. Count is one. Take is one. Save as text file. Save as text file, right? Yes. In this way, so collect, count, take, save as text file. Collect means in a Spark data object, right? Spark data object divided into multiple partitions, P1, P2, P3, and P4. P1 stored in, okay, P1 stored in system 1, system 2, system 3, system 4. If I say collect all these partitions data, collect is going to get collected. gets the output, right? All these partitions data will be count means how many? 1, 2, 3, 4. Take off 2. Take off 2 means first 2 outputs only takes. Take off 4 means takes all 4. Save as text file means if you want to save the output into a file, right? So here execute the first flow R1, R2, R3, R4, R1, R2, R3, R. Whenever you say R4 dot collect only, R1, R2, R3 flow executes. First R1 gets loaded. See, in Spark, excuse me. Yeah. R1, R2, R3, R4, right? R1 output is taken as input by R2. R2 output is taken as input by R3. R3 output is taken as input by R4. This is not executed. First R1 gets loaded into the RAM. And R1 output will be corrected as input by R2. When R2 is ready, R1 gets removed. When R2 is ready, R1 gets removed. When R all the 4 RDDs cannot be accommodated into the RAM. They cannot fit into the RAM. R1 of some TBs of data, R2 some TB, R3, R4. Those many TBs of data you cannot be accommodated within the RAMs, right? They are going to be stored within the RAMs. So when one RTD is ready, the previous one gets removed. When R3 is ready, R2 gets removed. When R4 is ready, R3 gets removed. Finally, this R4 output will be collected. And once the execution complete, R4 also removed, right? Now, for example, try to answer, right? I want the sessions to be interactive, right? If I say like this, R1 equal to
Sir, voice is breaking, sir. Sometimes it is not.
voice is breaking. Is it the case for everyone? Try to
Yes,
please.
sir.
Okay,
It's talking and not able to hear you. Next sometime.
sometime. Okay, one
No,
second.
sir, here is your voice is clear, sir. I think maybe their side it's problem.
Okay. Okay. Get it right? Yes. So R1 equal to sc dot text file. For example, observe clearly about this, right? So if you have understood this, understanding the practicals will be very simple, right? File1 dot txt. See, file1 dot txt R1 is an RTD created. If you load a file, a normal file using Spark context, RTD, Spark data object created. On that R1, if you perform any transformation, filter transformation, you are performing some filtering operations. R1 dot, right? R2 equal to R1 dot filter. R3, you get a new RTD, R2 dot group by. Group by operations. Transformation applied on a
Sir, what
RTD,
is
the result
Spark
also is an
context?
Yeah, we have got Spark context, right? Using the Spark context, if you load a text file. So Spark context object. Spark context using Spark context. See, in the interactive shell, this Spark context will be created, will be available automatically, but in batch mode,
Sir,
supposed
your
to
voice
create
is breaking,
a Spark context.
not clear.
Not
Sir,
clear.
sometimes it is breaking, sir, sometimes.
It's not clear.
So I think
Not clear also.
One second. Now are you able to hear me? Or still you have break?
Yes,
Yes, sir.
it's clear.
I'm able to hear you.
It's clear. Okay, fine.
Sir,
So-
this is a request. Sir, can you please explain Spark context with a real-time example?
Okay. Okay. Using Spark context class, Spark context object you will be creating. So Spark context object you will be creating, right? The Spark context object is responsible for everything. Spark context object is responsible for everything. For creating an RTD, for parallelizing, for converting one object, a Python object to Spark object, or to stop everything Spark context, right? So later in the programming part, I'll be explaining more on it. Now just a file, if you load by using Spark context, RTD created, I'm saying about the Spark context, right? In the practical part, I'll be showing you much on that, how to create it, how to use it. Transformations applied. Transformations applied on RTD, returns in RTD only. Returns a RTD only. If you apply action, Python object. If you apply transformation, right, Spark object. R1 dot filter, R2 dot group by.
Some noise is coming.
Hello. R4 equal to R3 dot map, right? Map with some map operation. So in this way, if you apply any transformation, how many RTDs will be in the RAM? Yes, try to answer it. How many RTDs will be in the RAM? R1, R2, R3, R4 is there, right? How many RTDs will be in the RAM?
Only one.
Only one. See,
Yes, sir, only one.
whenever I say R4 dot action, R4 dot collect, then only this entire flow executes. If I won't say this all not executed, right? 0 RTDs in the RAM now. Whenever you say the first RTD gets loaded, the output is taken by R2. When R2 ready, R1 gets removed. When R2 output taken by R3. When R3 ready, R2 gets removed. R4. R3 gets removed. When the total execution is completed, R4 also gets removed. Now, how many RTDs in the RAM? 0, right? One by one RTD they loaded and they are removed. Final output is collected, that also removed. How many RTDs in the RAM?
0.
0, right? So you can trigger the next flow. You can trigger the next flow. Observe this logic here, right? So understand this to make you much simpler. Just series flow, right? I was just showing you this figure from R1, R2, R3, R4. This is one flow R1, R2, R3, R5, R7. R1, R2, R3, R6, R8. First to execute the first flow. To execute the first flow. R4 dot collect. R1, R2, R3, R4. One by one they get loaded. When R1 gets loaded, when R2 is ready, R1 removed. When R3 is ready, R2 is removed. When R4 is ready, R3 is removed. When execution is finished, R4 also removed. No RTD in the RAM. No RTD in the RAM now. Now I can execute R7 dot collect, that is flow, second flow. R1 to R7. If you say collect, then only the entire flow executes. R1, R2, R3, R5, R7.
Sir, R3
When R, what is it?
three is a persisted now. That's why the flow will be R3, R5, and R7.
Still we didn't persist it. We didn't persist any RTD. So here you just observe this flow. R1, R2, R3, R5, R7. So first when R2 ready, R1 removed. When R3 ready, R2 removed. When R5 ready, R3 removed. When R7 ready, once the execution is completed, R7 also removed from RAM. When execution is completed, R7 also removed from the RAM. No RTD within the RAM. Now also no RTD in the RAM, right? Now I can execute one more flow. To execute flow 3, R1, R2, R3, R6, R8. Okay. Flow 1 is what? This one. R1, R2, R3, R4. Flow 2 is R1, R2, R3, R5, R7. We say R4 dot collect. First R1 nodes, next R2, next R3, next R4. When R2 is ready, R1 gets removed. When R3 ready, R2 gets removed. When R4 ready, R3 gets removed. Once the total execution completed, right? R4 also removed. No RTD in the RAM, right? Now flow to execute flow to. Flow to means R1, R2, R3, R5, R7. R7 dot collect. When R2 is west R1 nodes, R2 ready, R1 gets removed. When R3 ready, R2 gets removed. R5 means all the partitions of R3 gets removed. When R7, when total execution output collected, this also gets removed. Now no RTD in the RAM. No RTD in the RAM. Flow 3 if you execute flow 3. When R1, R2 ready, R1 gets removed. When R3 ready, R2 gets removed. R6 and R8, right? Everything gets removed. Means what is your observation here? All the RTDs cannot be accommodated if they get loaded into RAM. So when the previous next RTD ready, the previous one gets removed, right? So now what is the drawback you observe here? See this, first three flows, right? Even though the first three flows common, again in the second flow, again it is re-executing R1 to R3, R1 to R3. Already in the flow one, you executed R1 to R3, right? Why again you are re-executing R1 to R3 in the second flow and in the third flow, right? Why again it is re-executed, right? Yes. Okay. Okay, so the drawback is even though the series. Okay, it is again re-executing. So what we need to do? We need to persist the flow. We need to persist the flow whose output is commonly used by multiple. We need to persist among here. R3 need to be persisted, right? See this diagram, the same thing I said. When all the three flows are executed, no RDDs remains in the RAM. But in all the above flows, flow is re-executing from the beginning, even though the first three steps are same. So to avoid this, we need to identify the RTD whose output is commonly used by multiple flows and make it persist so that it will be available in the RAM and provides output to the different flows. In the above example, R3 output is used by many flows, so make R3 as persist. Make R3 as persist. If you persist, then for second flow and third flow, no need to execute from the beginning. No need to execute from the beginning. So I need to persist this. Observe this diagram, right? I will persist R3 dot persist. If I say this R3 never be, it won't be removed from the RAM so that it can give output to this and this, right? Now if I execute the flow one, assume this flow one executed. Now see this R1, R2, R3, flow one. When R2 ready, R1 removed. When R3 ready, R2 removed. When R4 ready, R3 won't be removed because it is persistent. Persistence means making the RTD available in the RAM even though the next RTD is ready. So once output collected, R4 also removed. Now R3 remains. Next, the second one. R1, R2, see this flow. R1, R2, R3, R5, R7. R1, R2. R7 dot collect. R7 dot collect. See the second flow once. Whenever you say this action only, then this entire second flow gets executed. This entire second flow, this one, gets executed only when you perform action on R7. Now, first what happens? R7 input is what? R6. R6 input is what? R5 input is what? R3.
So sorry to interrupt. Actually, we have discussed all these things, sir, and we came to case 5 also regarding persistence.
R7, yes. R7 dot collect, R7 input, okay. So what happens here, right? When R5 input is R3 means we can go from R3, R5, R7. So the flow is only from here. No need to execute from this, right? R3 is available in the RAM. When R3 is available in the RAM from the second flow, we no need to execute from the beginning. Right? Yes, understood, right? Yes. Now, so when we persist on RTD, right? No need to execute from the beginning. Flow 3 also. R3, R6, R8. No need to execute from the beginning. We can just execute from R3. This and this gets removed, but still R3 will be available. So if you persist in RTD, once your job is done, we can unpersist in RTD. Okay, now same it. I got some queries now. Now, first question. Observe this first question, right? What are the different ways to persist in RTD? This first one. Second question. What are the situations where RTD is removed from the RAM?
Sir, are you providing the notes after the class, or we can note down the?
What are the different ways? What are the different ways RTD unpersist in RTD? Unpersist. Different questions, right? You can see in interviews also they ask different ways to create an RTD. What are the different Spark transformations? Explain fault tolerant model in Spark. Generally, which RTD will be persisted? Generally, which RTD will be persisted? Rules in RTD persistence. Different persistence options. Can we persist to RTDs? So just you will get the solutions for all this today's session. That is what we have discussed, and in the next session also, right? So these are all these different queries, right? Transformation applied. On a RTD returns what? Action applied on a RTD. Returns what? Now, see these answers for this past. What are the different ways to persistence in RTD means? RTD dot persist. RTD dot persist. Whatever the RTD name, persist. And RTD dot catching. Difference between RTD dot persist and RTD dot catch means, see, we have got options in memory, in disk, in memory and disk, in disk only, memory and disk only, right? So this persist can use all options, uses all persist options. Can uses all persist options. Catching, you can use only memory option. Only memory option to be used. Okay. So more on this persistent cache we'll be discussing, right? Persistence can use all the persist options in memory, in disk, memory and disk, right? Cache only memory option to be used.
Sir, default will be memory or disk?
So if, for example, if you try to persist an RTD, this your RAM capacity, for example, 16 GB, for example, but the RTD capacity is 30 GB. Can you fit it? Default is RAM only, but it cannot fit into the RAM, right? Then your job will be failed, right? So in such case, we can go for disk option only. You can persist in disk. Means you need to use memory and disk option. If you give memory is available, it will be persisted in the memory. Otherwise, disk option.
Sir, I can't analyze it,
Yes.
but
You cannot.
RDD can get more partition, and each partition can execute on each machine. So how RAM space will be less to execute an RDD? Means every system has its particular.
For example, RTD size 10 GB divided into 10 partitions. 1 GB, 1 GB, 1 GB, 1 GB. Right? 10 partitions stored in 10 RAMs of 10 slaves.
Yes, sir.
10 RAMs can accommodate that, right?
Yes, sir.
So 10 RAMs are, see, 10 systems are running parallelly and processing that 10 partitions. The result is corrected by the next RTD.
Yes, sir. But what are the situations? Means taking an example, 16 GB of RDD size. 30 GB size.
No, what is your query?
Sir, if my question is that when the RDD size is much more, there are several systems to execute an RDD. Then how the RAM size will be deducted? How the RAM size is less than RDD? This is my question.
RAM size is less than RTD. Okay. For example, already your RAM size is okay. Just observe this. See this diagram once. Okay. RTD size 8 GB. RAM size 12 GB. This RTD can fit into the RAM, but RAM is busy.
Oh, sir.
Executing other RTD. RAM is busy executing other RTD. Only 4 GB available. In this 4 GB, can this 8 GB will it fit? No, right? No, right? So in such case, it will be persisted in the disk.
And sir,
From the disk.
how about other
What is-
systems? Means, are they busy? Means we are assuming the scenario where all the system RAM space are busy. At that time, the lifted place will be executed in a disk space.
10 systems are there, 8 GB RAM, 80 GB is there. 80 GB RAM. Your RTD size 60 GB. But when you try to do this, out of this 80 GB RAM, 70 GB busy, 70 GB is RAM busy executing other RTDs. Only 10 GB left out. Can the 60 GB fit into that? Means 80 GB means I'm talking about all 10 systems with 8 GB each. Understanding? 10 systems with 8 GB each. In that 8 GB, 80 GB, can this 70 GB busy executing other system, other. In that 60 GB, only 10 GB available, 60 GB cannot fit into it, right? Fine. Okay, fine. Okay, cannot fit into it. So what happens? It will be persisted in the disk. Immediately after some time, immediately the RAM gets free. Again, it will be removed from this. It will be removed. But after 95% of this RTD exit, after this, the output will be taken by the RAM. Right. So if unable to fit into the RAM, then only it will be persisted in the disk. Okay, fine.
Okay.
If unable to fit, so the queries, the answers for this, understood, right? If unable to fit into the RAM means, you may ask why RAM size won't be available means if they are busy executing other RTDs. So that the current RTD cannot fit into that, cannot be accommodated. In such case, it will be, okay, two situations. More on this persistence and cache I'll be discussing. What are the situations where RTD is removed from the RAM? What are the situations where RTD is removed from the RAM means? Can anyone say? When the next RTD is ready,
The node is down.
when the next RTD is ready, previous RTD gets removed. Previous RTD gets removed. When the next RTD is ready, previous RTD gets removed. Secondly, when the execution is completed, the last RTD gets removed. What are the different ways to unpersist an RTD? Unpersisting an RTD means first one, RTD dot unpersist. See, once your work is done, right? Yes. Once your work is done, forcefully unpersist. Forcefully unpersisting it by saying RTD dot unpersist. forcefully unpersisting it by saying RTD dot unpersist. Second, if session is closed, third, if server shutdowns, right? If server shutdowns. What are the different ways to create an RTD, right? So this I'll be discussing separately, right? That is, lot of discussion is required. Lazy evolution in Spark means if we perform action only, then the data flow gets executed. If we perform action, then the data flow gets executed. What are the different Spark transformations? Okay, some are like, as I said, so like, what are the different Spark transformations? What are the different Spark actions? So we'll be discussing more. We have got many inbuilt transformations, inbuilt actions. Okay. Explain the flaw tolerant model in Spark, right? Generally, which RTD will be persistent means whose RTD's output is commonly used by many flows. Rules in RTD persistence. We need to have a lot of rules, right, in RTD persistence. We need to follow, right? Yes. About this persistence also, we have a lot of discussion, right? Can we persist to RTDs? Yes, we can persist to RTDs. If their outputs are more used by many different flows. Transformations applied on RTD returns RTD only. Action applied on RTD returns action applied.
Result only.
Python objects.
These things you need to understand, right? Okay. Further discussions, right? Will be doing. Course content will be discussing, right? Yes. Spark RTD computations, persistence options, memory only, memory underscore disk and PySpark core computation, fault tolerance, different ways of creating. So examples and groupings and aggregations, various actions and transformations one by one in brief, right? I'll be discussing. PySpark SQL, mostly like will data frame concepts I'll be discussing. We have got a lot of things in this Spark SQL data frames concept, each one by one functionality with examples. Spark SQL functions, PySpark built-in functions, right? Built-in functions, right? One by one functions in brief. And from our external sources, deployment modes, PySpark applications, streamings, integration with Kafka, and these other things. Right. Okay.
So we have session tomorrow.
So there is no session tomorrow, right? So I'm out of station actually. Today also I'm out of station, right? So but still I'm taking a session, right? Once. So I'll do one thing. I'll just compensate, right? Next week I'll be taking 1.5 hour extra, right? On Saturday and Sunday I'll be taking 1.5 hour extra on the next week, right? So I'll stop for here. We'll continue with the practical part. In the next, I'll be going with the practical part. Next Sunday, I will be having practical part. Saturday, I'll be demonstrating about the software, other things, and more on this, some different ways of creating RDDs for different persistence options, rules in persistence options I'll be discussing. On Sunday, we go with the practical part. Fine. Okay.
Yes, sir. Sir, in the meanwhile, can you share basic Hadoop HDFS videos?
Yeah. I need to forward it today itself. I'll just say down team to forward it, right? So just within 1 hour or 2 hours, you can check, right? Your Google Drives.
Okay.
Fine.
Thank you.
So, hello.
Yes.
Yeah, one thing, sir. Actually, I'm new joinee in PySpark batch. So, how will get the previous session? I need to understand the basic one also.
Yeah. You'll be getting all the recordings, right? Once you get enrolled, right? From starting
Yeah.
all.
Okay.
Fine.
So actually,
You are
the
supposed.
batch. I mean, what is the starting date of this batch? I mean, start date.
So not only that introduction part is completed previously. That
Okay.
again, I just have given, right? An overview of it today. In the today's class I have given, and also you can go through to the videos of it, right?
Okay. Okay, sir.
Fine.
Sir,
Okay,
can you
yes.
provide the entire videos of this class instead of attending classes? I want offline videos in my Google Drive so that I can go through in limited time. Is it possible?
Yes. You'll be getting the videos, right? Every day, as you can see, if once you get enrolled, right?
No, actually, I
You'll
am
be
asking
getting.
any previous batches, all videos exist. Can you provide so that I won't attend the class? I can go through offline videos. I already paid money,
What-
but I just
can
want
just
offline
okay.
videos to go through with a limited time because
Okay.
it is
So
taking.
a WhatsApp group is okay. So you can just ping me on this number, right? 9912621686. Everyone. If you have got enrolled, right? I'll be just adding to the WhatsApp group. And if you want the videos, other things as you are asking, right? It can be provided, not a problem. Previous batch, right? Yes.
Sir, can you tell me the
So-
number again?
You can see the chart panel, right?
Okay.
So you can just ping me to get added into the WhatsApp group, and also
Okay.
any other queries, right? I'll just, yes. Okay, fine. So I'm stopping for now and we'll continue next week, right?